Machine learning, let's start with the introduction. So, machine learning is a branch of artificial intelligence that enables system to learn and make decisions without being explicitly programmed. It empowers computers to improve their performance by learning from data. As its core, machine learning involves algorithms that can identify patterns, make prediction, adapt to new situations. These transformation technologies reshaping industries by automating tasks, improving decision making processes, creating new possibilities in areas such as healthcare, finance, retail, and beyond. The concept of machine learning is not entirely new. It dates back to the 20th century when computer scientists began exploring how machines could learn from data. However, it is only in recent years that machine learning has gained significant attention thanks to advances in computing power, availability of large data set, and the development of sophisticated algorithms. So, we will deep dive into the fundamentals of machine learning, exploring its type, algorithms, application, challenges, and the future trends uh, by this. And by all of this presentation, you're gonna have like comprehensive understanding of what machine learning is and why it's considered game changer in the world of technology. So, how it started, or the evolution of machine learning. Machine learning has evolved over several decades from theoretical concepts to practical tools that power modern technologies. Understanding the historical context of machine learning helps to appreciate its current capabilities and future potentials. So let's start with the early foundations. The roots of machine learning can be traced back to 1950s. So one of the earliest milestones for development of first artificial neural network by Frank Rosenblatt in 1958 called the perception. The perception was designed to mimic the way human brain process information. However, due to limited computing resources, theoretical challenges, progress in neural networks stagnated for several years. In the 1960s and 70s, researchers focused on symbolic AI, which involved rule based systems to stimulate human decision making. However, these systems struggled with scalability and adaptability. As a result, interest shift back to data driven approaches, laying the groundwork for modern machine learning techniques. So, the emergence of uh, modern machine learning, the 1980s saw a resurgence in machine learning research. The back propagation algorithm introduced by David Rumelhart and Geoffrey Hinton revolutionized neural networks by enabling them to learn more complex patterns. This breakthrough remarked a turning point in development of machine learning. And in the 1990s, machine learning gained traction in the academic community with focus on statistical learning. Algorithms like support vector machines, SVMs, and decision tree became popular. Researchers also began exploring unsupervised learning techniques, which allow machines to discover patterns in data without labeled examples. And in the 2000, witnessed the rise of big data providing machine algorithms with the necessary fuel to thrive. So companies like Google, Amazon leverage machine learning to enhance search results, recommendations, customer experience. The development of deep learning subfield of machine learning that uses large neural networks further accelerated the progress. So so today, machine learning is a critical component of various technologies from virtual assistants like Siri, Alexa to autonomous vehicles and medical diagnostics. So So we have to understand the core concepts of machine learning. To grasp the essence of machine learning, it is essential to understand its core concepts and principle. The first is data and features. Data is the foundation of machine learning. Machine learning algorithm require data to learn patterns, make predictions. The quality and quantity of data significantly impact the performance of machine learning models. So first, like training data, the data set is used to train machine learning model. Then is test data, which is used to evaluate the performance of trained model. And then features the individual attributes on variables in the data that algorithm uses to make predictions. And then is algorithms. Machine learning are mathematical models that process data to identify patterns, make decisions. Different type of algorithms are suited for various tasks such as classification, regression, clustering, and more. And then is model training and evaluation. Training a model involves feeding data into algorithm and adjusting its parameter to minimize error. Evaluation involves testing models' performance on unseen data to ensure its accuracy and generalization. And then types of the machine learning. So, machine learning can be broadly categorized into three types: supervised learning, unsupervised learning, and reinforcement learning. So, in supervised learning, the model is trained on a label dataset where the input data is paired with the correct output. The algorithm learns to map inputs to the corresponding output. The example is spam detection, image recognition, fraud detections, and common algorithms like linear regression, logistic regression, super vector machines, neural networks. So, if we talk about unsupervised learning, deals with unlabeled data. Algorithm tries to identify patterns, structures in the data without predefined output. If we talk about customer segmentation, anomaly detection, recommendation systems. So these are the examples, and common algorithms are like k-means clustering, hierarchical clustering, principal component analysis, PCA. And if we talk about reinforcement learning, which involves an agent that learns to make decision by interacting with environment, the agent receives feedback in form of rewards or penalties based on its actions, like robotics, game playing, self-driving car. These are the example of reinforcement learning. And they uses common algorithm like Q learning, deep Q network, DQN, policy gradient methods. And so popular, so these are the machine learning. So popular machine learning algorithms. They are like numerous machine learning algorithms with each its strength and weakness. Understanding these algorithms is crucial for selecting the right approach for specific task. Let's start with linear regression. Linear regression is a simpler yet more powerful algorithm used for predicting numerical values. It establishes a linear relationship between the input variable, features, and the output variable. Then is logistic regression, which is used for binary classification tasks. It predicts the probability of an output belonging to a particular class. Third is decision trees, which are versatile algorithms that can handle both classification and regression tasks. They split the data into branches based on feature values. And then is SVM, super vector machines, are more powerful algorithm used to for classification tasks. They find the optimal hyperplane that separate data points into different classes. And neural networks are the foundation of deep learning. They consist of layers of interconnected nodes or neurons that process data and uh, lean complex patterns. And then is clustering algorithms group. Similar to data point together, K-means clustering is a popular unsupervised learning algorithm. And in the last, dimensionality reduction algorithms. Uh, Dimensionality reduction techniques such as PCAs, they reduce the number of features in a dataset while retain essential information. And if we talk about application of machine learning, uh, machine learning has numerous real world application across various industries. For example, if we talk about healthcare, and it is used in medical diagnosis, personalized treatment, drug discovery, and if we talk about finance, it can be used for doing fraud detection, credit scoring, algorithm trading. So these are the examples. So similarly to retail, the recommendation system for the customer, customer segmentation, inventory management, and in automotive, if we talk about autonomous vehicle, predictive maintenance, traffic protection, and in the last, entertainment, content recommendations, sentiment analysis, video analytics. So these are the examples of entertainment. But every but it has like challenges in machine learning as well. While machine learning offer immense potential, it also comes up with challenges. For example, data quality. Poor data quality can negatively impact the performance of machine learning models. Overfitting and underfitting. Uh, the overfitting normally occurs when a model performs well on training data but poorly on test data. And underfitting occurs when a model fails to capture underlying pattern in the data. And then is like bias and fairness. Machine learning models can perpetuate biases presenting in the training data, leading to unfair outcomes. Then interpretability, understanding how machine learning model makes a decision in a crucial, especially in critical applications like healthcare and finance. And in the conclusion, machine learning is a rapidly evolving field with the potential transform industries and improve our daily lives. By understanding its core concepts, type, algorithm, application challenges, we can better appreciate the impact of machine learning and harness its power for solving real world problems. As we move forward, machine learning will continue to shape the future of technology and make it an essential area of study and innovation. Thank you.